Alright guys, we're going to do a few problems. This should be done on page 109 of your interactive notebooks. So remember, if you run out of room, make sure you continue this on a separate piece of page and then glue the separate page into the notebooks. Alright, so part 1. The first problem that I want us to do, and this one's actually not a problem, I just want us to be able to identify this, is we're going to first start by listing all the group A elements, so from 1A all the way to 8A. Okay, now that we've listed all the group 1A through 8A categories, I want you to go through and list the charges. I'll get it started for you. 1A is a +1 charge, and 7A is a -1 charge. You fill in all of the remaining charges. Once you've filled these in, your chart should look like this. Okay, we discussed this concept a few months ago, so I know this is review and it's old for a lot of you and you might not remember it, but basically if an element is in group 1A, then it has a +1 charge. If it's in group 3A, it has a +3 charge when it forms an ion, and so forth. Alright, question number 2. For this problem, I'm going to give you an equation, and you have to use your activity series, which you can find on the front of your green paper that we had last class. This paper is the single replacement reaction worksheet, and that is on page 108 of your notebook. So go ahead and grab that out if you don't have it out already. Alright, so now here is the equation that you're going to use. Copper is reacting with Al2, SO4, 3, and you need to tell me if a reaction will occur or not. That's all I need to know, is will a reaction occur or not. Now, in order to solve the problem, we first need to look at what we're trying to compare. Right now, we know that this SO4, if we look at our table of polyatomic ions, that's going to have a negative charge. This aluminum has a positive charge, and we know that copper, from our list of polyatomic ions, has a positive charge. Now, before we go any further, I do want you to get out your list of polyatomic ions, your list of common ions. This is on page 62 of your interactive notebooks. Go ahead and take that out, and we will use that to solve several of these problems right now. Now, going to that problem, back to this problem, if we look at that list, we know that SO4 has a negative charge. Al is in group 3A, so it has a plus charge, and copper has a plus charge as well. So when we do a problem like this to figure out if it's going to be a reaction, we have to compare two things of like charges. In this case, a positive copper with a positive aluminum. Those would be the two things that get switched, that switch each other. Now we have to be able to check and see if they actually do switch each other and form a reaction. If we look at our activity series, we find that copper is way down here and aluminum is higher up. Now, because aluminum is higher up than copper, remember, something only replaces it if it's below it. Copper is below aluminum, so the copper cannot replace the aluminum. Remember, it can only replace it if it's below it. So because copper is below aluminum, it cannot replace it. Alright, for problem number 3, I'm going to give you two elements, and you have to figure out what their subscripts are going to be. Now, in order to solve this, you need to write out BaPO4. The PO4 is polyatomic ion, so I would put it in parentheses. And now you are filling out the subscript. So the subscript here and subscript here. I'll give you a hint. You have to use the charges and use the crisscross method that we learned about a month or two ago. Alright, take a minute and go ahead and finish this problem. Alright. Once you're done, let's go ahead and double check it. If we look at barium, barium is in group 2A, so barium has a +2 charge. Okay, further, using your list of common ions on the blue paper on page 62, we find that PO4 has a -3 charge. So using the crisscross method, we're going to take this +2 charge and write it right below here as that subscript. We're going to take this -3 and we're going to put it right here. Now remember, with the subscripts, we don't need to take the positive and the negative, we just need to take the numbers. So when we do that, our answer will look like this. And that's our final answer. Alright, for our last question for part 1, I'm going to give you an equation, the reactants at least. You're going to predict whether or not it's going to form a reaction, and if it does form a reaction, you will write the correct subscripts and then balance. So this is putting everything together. Alright, so the first thing you're going to do is predict whether or not a reaction occurs. Secondly, if it does, you need to predict what the products will be. Third, you need to check the subscripts, make sure the subscripts are correct. And fourth, once your subscripts are correct and you have your products, then you need to balance the entire equation. And then you will be done. Alright, so for step 1, we need to predict whether or not a reaction occurs. Again, we have our list of reactivity. Aluminum is up here, Pb is down below, so aluminum does replace Pb. So a reaction will occur. Step 2 was predict the products. So if we take aluminum, aluminum has a plus charge, Pb also has a plus charge, so we know that aluminum is going to replace Pb. So our products would look like this. The Pb gets kicked off and is just kind of by itself. The aluminum is now with the NO3. And those are our products with the exception of our subscripts. We need to double check, make sure our subscripts are correct. Alright, step 3, check the subscripts. Pb is a metal, so usually when a metal is by itself, it's just monatomic. If it's in group 8A, then group 7A. If it's in group 7A, then it's usually diatomic. So that's why something like chlorine wouldn't be written as chlorine, it would be written as Cl2. Something like iodine wouldn't be written just as I, it would be written as I2. But this is a metal, so metals don't follow that same trend of being diatomic. Okay, now on to the aluminum nitrate. We know that aluminum from our table is in group 3A, so it has a +3 charge. NO3 from our polyatomic ions has a -1 charge. So using our crisscross method, we take the 1 here and we put it here, which it's already written, so we don't really have to change much. Then we take this 3 and we write it right here so that we have 3 nitrates. So this is what our equation will look like just before we balance it. Now that all the subscripts are correct, now we can move on to step 4, which is balancing. Okay, when I look at this, I see that we have 1 NO3 over here, and on this side we have 3 of them. So that's going to be the first thing I balance. I'm going to put a 3 right here to balance the NO3s, and so now they have 3 NO3s on the left and 3 on the right. Those are balanced. But by changing this 3 right here, by putting that 3, that changed my number of PBs, so to fix that, I need to put a 3 right here. Now let's go through and double check. We have 1 aluminum on the left, 1 aluminum on the right, aluminums are balanced. We have 3 PBs on the left, we have 3 on the right, those are balanced. We have 3 NO3s on the left, we have 3 NO3s on the right, those are balanced, so this equation is now balanced. Alright, now we are moving on to part 2. So go ahead and make sure you separate this, and if you need more paper, make sure you grab another piece of paper that you'll attach to this page. Alright, for this part, before we get started with the questions, I'm going to give you 3 reactions. So you want to make sure you write these reactions down, and I'm going to tell you whether or not a reaction occurs or if there is no reaction. Alright, here are the 3 reactions, so go ahead and write those down. Go ahead and take a minute or so to do that. Okay, next I'm going to tell you which reaction reacts and which one has no reaction. Okay, so from this we see that the first reaction, reaction A, is the only one where a reaction actually occurs. Number or letters B and C, there's actually no reaction. Now, before we do this part, I'm going to go through and I'm going to highlight all of the metals that are involved in these 3 equations. So for equation A, we have zinc and iron. For equation B, we have copper and iron. And for equation C, we are going to compare, or we have copper and zinc. Now, for question number 1. For each reaction, you're going to circle the metal that was most reactive. All right, so again, you're circling the metal that was most reactive. So for example, if we had aluminum plus copper chloride, if I tell you that a reaction did occur, then that means that aluminum is more reactive because it is replacing the copper chloride. However, if I say that a reaction did not occur, that means that copper is more reactive, and so copper is going to stay right where it is. So if there's no reaction, then this one is more reactive because it stays where it is. If there is a reaction, then this one is more reactive because it replaced the least reactive element. So go ahead and take a minute and answer question number 1, circling the metal that was most reactive in equations A, B, and C. Okay, once you've done this, this should be your answer in equation A. Because a reaction took place, zinc was most reactive and replaced the Fe. In part B, there was no reaction, so copper did not replace the Fe. So that means that Fe is the most reactive one in that equation. The same thing goes for part C. Zinc is more reactive than copper because no reaction took place. Alright, and now for question number 2, you are going to fill in the chart that shows the activity of the 3 metals. Now you are not allowed to use your activity series chart. You are creating one by analyzing these 3 elements. Alright, so this is the chart you are going to fill in. The element that is most reactive, you'll put right here. The element that's least reactive, you'll go down here. And the one that's in the middle will go right here. Alright, so go ahead and take just a minute to go ahead and with your partner figure out how to fill in this chart. Alright, so for equation A, we said earlier that zinc was more reactive than Fe, iron. For equation B, we said that iron was more reactive than copper. And for equation C, we said that zinc was more reactive than copper. So we need to use this evidence to fill in what the most reactive is. Okay, so from A, we know that zinc is higher than iron. So we know that zinc should be up here, iron should be below zinc. From equation B, we know that iron is above copper, so copper should be down here, and letter C confirms that zinc is above copper. So when we do that, we can fill in our chart. Zinc is the most reactive of the 3, iron is the second reactive, and copper is the third most reactive. And that concludes page 109 of your notebooks.